This is the demo video of MDebug tool. Debugging is a crucial yet labor-intensive and time-consuming activity to ensure software quality. To facilitate debugging, many debugging aid methods are proposed. For example, for C programming language, GDB is used for debugging. For Java, IDEs like Eclipse provide debug perspectives. Moreover, automated fault localization techniques are proposed to reduce debugging efforts. These techniques calculate each program statement's risk of being faulty and then visualize this information by rendering a statement ranked list or highlighting suspicious code. Here comes the problem. How do we know such debugging aids are effective in real-world environment? To solve this problem, we implement MDebug, a debugging behavior tracker. MDebug highlights suspicious code to aid debugging and also records user debugging behavior. This is the architecture of MDebug. Basically, it's an Eclipse plugin that relies on a web platform, mooktest.net. It provides MDebug with software artifacts for debugging and then analyzes user behavior logs collected from MDebug. MDebug is essentially an Eclipse plugin composed of two parts, Code Highlighter and Behavior Recorder. Code Highlighter combines static and dynamic program analysis to achieve fault localization. Static analysis is used to generate control flow graphs, which are later used for mapping statements with dynamic execution profile generated with the help of suit and JUnit. The results from both static and dynamic analysis are then used by fault localization formulas to calculate suspiciousness scores of statements. Popular formulas are Tarantula, Jacquard, OKI, and so on. This is how users interact with MDebug. First, log in the system. We can get the authentication code from the website. Then download the software artifacts for debugging tasks. Now we have the program. We have both the source code and also the JUnit test cases. After that, we can click Run and get a formula selector. We select a suspiciousness formula. Then you see in the score panel below, we have two failed test cases. And in the editor, some of the code are highlighted in red. The statement that is in vivid red is most suspicious, and others that are in lighter red are secondary suspicious. And also on the right, we have an overview of all suspicious statements. And if we fix the bug and run again, we can see that all red parts disappear. And also in the score panel, there's no failed test cases. When we finish the debugging task, we can submit it to the web platform for future analysis. All user behaviors are recorded by MDebug. Behavior Recorder listens to users' debugging behavior and records them in logs. Various kinds of listeners with recall functions are added to Eclipse Workbench parts. When triggered by user activities, the recall functions record the activities in user behavior logs containing basic information of timestamps, log types, contents, and so on. This is what a user behavior log looks like. The log entries fall into 5 categories: workbench activities, cursor positions, breakpoint activities, file modifications, and JUnit execution. Typical workbench activities include brought to top, activate, deactivate, open, and close. Cursor position is usually where users focus their attention. We record such kind of activities to review the movement of users' attention. Setting breakpoints is a convenient way of debugging. We record actions of adding or removing breakpoints. File modification records where and how users modify their files when debugging. Modification includes insertion, deletion, and alteration on files. JUnit execution records JUnit results, namely passed and failed test cases. It serves as a proper monitor of whether the program failure is fixed or not. Then the log is submitted to mooktest.net, where it is analyzed. This is the end of MDebug demo. Thanks for watching.